Welcome to the Fields and Keys Participation Project for the WV K-12 Education problem. In this project, we're going to take a look at a sample database and we're going to determine appropriate field types and keys for the tables that are in this database, as well as determine what relationship should exist between the different tables. To get started, I've downloaded and extracted the provided data files, and I've opened up the starter file in Access. This is the same basic database that was from the Access Basics Participation Project, with one really key difference. If we go and take a look, all of the keys have been stripped out of the tables. Also, all the data types have been set to short text, which might be appropriate for some fields, but not for others. We need to go and determine for each of these tables what the appropriate type should be for each of these fields, and what fields should be the primary key or should make up the composite key. We're going to do that first, and then we're going to take a look at what relationships we want to have between these tables. And one thing that we're going to want to check when we're done is to make sure that each of the queries here go and run successfully. If some of the queries don't work correctly, for example, the high graduation rate query here does not work correctly right now, it tells us that we have a data type mismatch. That's because we're trying to go and do a numeric filter for the greater than 0.9 on a text field. All these queries should run correctly once we have our field set, so we'll want to make sure that that is the case. What we're going to do to determine the appropriate field types is just work through these tables one by one. We'll first open up the table in Datasheet View to see what data is there now, and then we'll go head over to Design View and set things up. So right now, with analysis questions, which I opened by double-clicking on it, there aren't any records. But we do have these two fields, question number and response. I'm going to head to Design View by clicking this button here at the left side of the home ribbon. So for question number, we're just going to be storing basically the number and letter of whatever question we're answering. That's good as text, and short text is appropriate because it's going to be less than 255 characters. Now, we could actually tighten up the field size down below, but leaving it at 255 as the maximum length is okay. There's not a requirement that we go and tighten it up. So I'm just going to go and leave this field size alone, and we'll leave this data type alone as well. That should stay as short text. For response, though, we need to do some thinking. So with response, we want people to be able to write several sentences, potentially, to go and respond to that analysis question. When you get in the context of writing a couple sentences, 255 characters is not necessarily enough. We might need some more room. So what I'm going to do is I'm going to click on the drop down here for the data type, and I'm going to choose long text, which is designed for text, but it'll allow me to enter more than 255 characters. So that's going to be a good change there. We've gone through each of the fields for their data types. Now let's think about what our primary key should be. And we want the primary key to be something that's going to be unique, and also preferably something that's going to be short. Question number should fit the bill because we should only have one record for each question, and also we only have a couple characters that we're going to be typing in for each of the question number field values. So this is going to be a good primary key for us. So I've clicked inside of the question number row here, and then on the Table Tools Design ribbon that's open, I'll click on the primary key button, and you'll see it can go and add this little key symbol here to designate that that is the primary key. I'm going to go ahead and save my changes here. That is one of the cases where you do need to save things in Access before they get committed, is when you go and change the design of a table. And I'm going to go ahead and close out of this table now. Let's continue on to the districts table. We'll double click to open this up, and you can see we have two fields here. One has the name of each of the districts, and the other field has the region which that school district is located. And we can see that the values that are in the district field here are unique. There's one record for each school district. Region gets repeated a lot, though, since there's multiple districts in each region. For example, Hampshire, Hardee, and Grant all list Potomac Highlands here as their region. So that's going to tell us that district will be our choice here for the key for this table. Let's go head over to Design View and we'll get things set up. I'm going to click the button here on the Home ribbon. Since we said that we want district to be the primary key, I'm just going to do that right away. I'm clicked inside the district row and I'll click the primary key button. In terms of the two fields, they're both set to short text right now, and that's a good data type for us to use because we're going to be storing text that's less than 255 characters. There's no reason for us to go and have long text or anything like that. Short text is our best choice here. So we're done with this table for right now. We'll go ahead and click Save, and we'll close it out. Things begin to get a little bit more complicated when we go into the district statistics table. Let's take this one here and open it up. So we have a couple fields. We've got the name of the district, that's text. We have the school year, and because this actually has a dash in it between the start and end years, this has to be text. But then we have some numbers. We have the population, which is a whole number, and we have the dropout rate, which we're seeing represented as a decimal here, but we know that this is actually a percentage. And if we go and look at our data and think about our keys here, there aren't any values that by themselves are unique. We have the school year repeating, we have the district repeating, we potentially have the case where the population could repeat, so that's not going to be a good choice, and same goes for the dropout rate. As we go and set up this table here in Design View, we're going to have to use what's called a composite key. That's where we take multiple fields and collectively treat them as a key. So we know that there should only be one record for each school district for each school year. We can go and treat those two fields together as the key for this table. So let's go ahead and do that. I'm going to go and select district by kind of positioning my mouse over the little gray bar to the left of district. And if I hold down the mouse button, you can see it's got this arrow. I'm going to drag down to select school year. On the Table Tools Design ribbon, I'm going to click the primary button. You have to have both fields selected at the same time, or if you have more fields than two, all the fields selected at the same time when you click the primary key. If I go and just set one field, I can't go and choose the other one. You've got to select them both at the same time and then set them all to be the primary key at that same time there. For our district, short text is going to be a good choice because it's text and it's less than 255 characters. For school year, we said we need to have this be treated as text because of the dash. It's also under 255 characters. For population, this is actually a number. So I'm going to go ahead and set that to be number. Now down at the bottom, I want to go and take a look at the field size that we're using. We're working with whole numbers since we don't have fractions of a person. So we're going to want something that involves an integer. Byte really only works for very small numbers. You're pretty much never going to go and use it. The two options you're going to use for whole numbers are either integer or long integer. Integer can go and store values that are between minus 32,000 and positive 32,000. Long integer can store values between minus 2 billion and plus 2 billion. So when we're thinking about population, while some West Virginia counties do have a population that's less than 32,000, there are some that are larger. So we need to go and choose the field type and size here that's going to be able to store our largest possible value. And none of the counties are more than 2 billion people. So long integer's a fairly safe decision here. In general, it's okay to just go ahead and kind of use long integer as your default value. If you choose a smaller size like integer, it might save you a couple bytes in file size, but it's not a huge deal anymore. It used to be more of a concern than it is nowadays when memory and disk space is cheap. I don't need to necessarily format this number anymore. If I wanted to, I could go and say that I want to have, format as a standard type here, where it would have the comma and I can control how many decimal places. While I can certainly do that, it's not strictly necessary. So I'm just going to leave that alone. For dropout rate, this was what we said was going to be a percentage. So that's going to be a number as well, but it's not an integer because percentages are essentially represented as decimal numbers between 0.0 and 1.0. So we need to have a field size that's going to keep track of that decimal part. We're going to use double for that. There is this one that's called decimal, but it has its own special use case. This one is pretty uncommon. Normally, if you need to deal with the decimal point, just go with double. So that's what we're going to do there. And we do want to go and format this as a percentage. So from the format drop down here, I'm going to choose %. If I want a certain number of decimal places, I can go and specify that, or I can leave it as automatic. And I'm just going to do that. I'm going to save my changes here. When I do go and save my changes, I'll get a warning sometimes that some data might be lost, and that would be because I am changing to potentially a more restricted field size, where I'm going through and changing from text to number. That's normally going to go and trigger this. In this case, I'm going to go ahead and tell it, yes, I want to continue. And then I'll head over to datasheet view, and we can see our values here. And we didn't actually lose anything. For the number of field sizes that we chose, everything was big enough to store the values that we had. So district statistics now is in good shape. Let's take a look at schools now. So we have 4 fields here. We have a school ID, school name, the county in which it's physically located, and a field that says whether or not that school has been closed, and it's just storing yes or no values. Let's go ahead over to design view, and we'll start off by figuring out what an appropriate key is going to be for this table. When you have things that have ID in the name, that's generally going to be a giveaway that's probably a good field to go ahead and use. So what we have here is this school ID field that is designed to be a unique identifier that can identify every school in West Virginia. Since all of our data here is for West Virginia and it's supposed to be a unique identifier for West Virginia, that means it would be a good primary key. And in fact, that is going to be the field that we want to use for our primary key. Now, if we were to take a look at the school names, we have this potential that there could be schools that share the same name across the state. Every name may not be unique. So school name would not be a good candidate for primary key. We potentially could go and use a composite key involving the school name and the county, since presumably you're not going to see a school name repeated within a county. You could use those 2 fields together as a composite key, and that would work. But if there's an option that's available to use as a primary key, you want to go and take that over the composite key. Keys are going to perform better if they're as short as possible, and having only 1 field in the key is going to perform better than having 2 fields. So that's why I'm using school ID as my primary key here and not a composite key with school name and county. In school ID, if we go back, let's go ahead and save our change here. And then we'll go back to datasheet view. You can see we have leading zeros before these values. These were IDs that were assigned by the West Virginia Department of Education. And these leading zeros matter because the first 3 digits are a code for the county where the school is located, and the last 3 digits are a code that's specific to that particular school within the county. So we need to keep all 6 digits, including those leading zeros. If we went and changed this to be a number type, we run the risk of losing those leading zeros. So we're going to leave this as short text. The name obviously is text, and it's going to be less than 255 characters. So it can stay as short text. Same thing goes for county. For closed, we said that we just had those values that were yes or no. And there's actually a special type of field called a yes-no field that I can choose from this drop-down list here that's designed for that particular case. Yes-no stores either yes or no. It's either checked or not checked. Let's go ahead and save our change now. Again, I'm getting this box warning that some data might be lost because I was changing this from short text to yes-no. Since every value that was there was a yes or a no, I'm not actually going to lose any data, but Access is just warning me that something could happen depending on what values I had stored. I'm going to tell it that yes, I want to continue. And we'll go ahead back over to Datasheet view, and you can see the ones that said yes before are now shown as checked. So for example, Mount Vernon Elementary and Volga Century Elementary in Barber County are both closed. Those ones get checked. The ones that were no are unchecked. School statistics is the most complicated table in this database. There's a bunch of fields going on here. So we have an ID field. Then we also have a field that's called school ID. And if we look at these values, these look like the same type of values that we saw from our schools table. In fact, these are actually related to those values in the schools table. We have the school year, managing district, what grades are served, what type of school it is, and this is a text code that actually is going to go and relate to the table we'll look at next, school types. We have the enrollment in the school, which is a whole number. The attendance rate, that is a percentage, is what these are supposed to be, values between 0 and 1 or 0 and 100%. The graduation rate we don't have for everything, but in these cases where we do have a value, these also look like there should be percentages. We have the number of students who took proficiency tests, and these are whole numbers. And then we have the scores on the proficiency tests, and these are also looking like percentages. So let's go ahead over to Design View, and we're going to set up the field types for this table. We're going to come back to ID. We'll do that one a little bit. School ID, since this one is going to be related to the school ID field in the schools table, and it's short text there, it needs to be short text here. You need to have the matching field size and data type set when you're going and using a field inside of a relationship. School year has a dash in it, so it needs to be text, and school year here is also going to relate to school year in the district statistics, and that's short text there. Managing district was the name of the district. That's text, so short text is a good choice there since it's fairly short. Grade served has spaces and dashes in it and sometimes letters, so that should be text as well. School type abbreviation was letters, that should be short text. This is where things start to get a little bit different here now. The enrollment we said was whole numbers. So I'm going to go and change the data type to be a number here. Enrollment in West Virginia schools is relatively small. None of these values are larger than 32,000. So I can actually get away with an integer field size, although if I wanted to leave this as long integer, that would be okay too. Attendance rate we said was a percentage. So we want to go and change the data type to be a number here. We have to make sure that we adjust the field size, otherwise it's going to lose the decimal part. That's actually going to be able to represent values between 0 and 99.9%. So I'm going to change the field size to be double, and I'll format this as a percent. Do the same thing with graduation rate, change it to a number with a double field size, format it as a percent, and we'll do the math and reading proficiencies as well because those are all going to be percents. So double and percent, and reading proficiency will be a number that's a double and a percent. For students tested, this was a whole number. So I'm going to make this be a number, and number of students tested is less than 32,000, so I could do long integer, but just regular integer is fine. And we have one more field we have to go back up and take a look at, and that's that ID field. Let's go ahead and save our changes right now. And I'm going to tell it that I want to continue even though some data might be lost. And we're going to go back to Datasheet view. We can see that we have identifier numbers for each of these records. And each of these numbers is actually intended to be unique. These values should not be repeated. So this is going to make for a good primary key for us. So let's actually go and set this as our primary key, because that allows us to uniquely identify each row. We could also potentially use school ID and school year together as a composite key, but since we have this ID field that has a unique value, that's going to be an even better choice. For our data type, ideally what we would really want to go and use is auto number. Auto number is a special type in Access that every time you go and create a new record, it goes and automatically assigns it a new value. It just kind of keeps track of what the last number was. It adds 1 to that and assigns that value for the next new record. Access does not allow you to go and take an existing field and change it to auto number. You can only use auto number on brand new fields. This would be the type of case where we would want to use auto number. It's a primary key here, and we're just using it as a number to uniquely identify each row. But since I already have some data in it, it's not a brand new column, I can't do auto number. What I can do though is just regular number. So I'll have to make sure that I enter a unique value if I go and add any new records, but at least using number here, it's going to allow me to make that change. It would not allow me to set it to auto number. I'm going to go ahead and save things. Again, I get the warning that some data might be lost because I'm going from text to number. We'll tell it yes. And we can head back over here and we can see these values. And so there's 5,361 records, and our numbers go up through 5,361. I'm going to close out of school statistics here. For our final table here, school types, let's open it up. And you can see that we have text for the school type abbreviation field, and we have text for school type name. And if we look at the data, we can see that the abbreviations are all unique, and so are the corresponding names. So we'll head over to Design View. Since the values in each of these fields is unique, technically either of them could serve as primary key, but I'm going to go with abbreviation, and there's two major reasons for that. First of all, the abbreviation is shorter, and when we're dealing with keys, shorter is better. The other reason is since we have that corresponding field over in the school statistics table, we need to make sure that that relationship that we'll be creating to that corresponding field here momentarily has a key on one end of it so that we can set referential integrity. So that's going to lead also to us using the abbreviation as the primary key. So when I'm clicked here inside of this field, I'm going to set primary key, and we'll go ahead and save this, and we'll close. Just to make sure that we've chosen the correct data types and field sizes, I'm going to try running all of my queries. It's not a guarantee that I've done everything correctly, but if they all run without an error, that's a pretty good sign normally. So you can see here I'm running each of these queries, and they all are displaying data. So chances are we've done things correctly. We'll go ahead and close all these queries. I'm just going to right click on the tab and tell it to close all. Now that we've set the data types and keys for our tables, let's go and see what we need to do with the relationships between the tables. Access is an example of what's called a relational database. That means it's designed to go and use relationships to tie together pieces of data across different tables. The relationships are how things in different tables are associated with each other. To specify relationships, on the Database Tools ribbon, we want to click the Relationships button. Now, in this particular case here, you should see all of our tables listed except for analysis questions, which I deliberately did not add when I set up this project. If you need to go and add tables, you can drag them over, or you can use this Add Tables window. In our particular project here, analysis questions is not going to have any relationship to any of the other tables, because the values that it stores are kind of self-contained. They're just answers to those analysis questions. Normally in a database, every table is going to be related to at least one other table, sometimes multiple tables. You can see here for each of the tables, we have a listing of the fields in that table, and then the little key icon beside the names of the fields that make up the key for that table. So like school type abbreviation is just the only field in the key for school types, but district statistics has a composite key where it has both district and school year, so it shows a key for both of those. What we're going to do here is identify which tables have related data, and we're going to go and create relationships between those tables. A good place for us to start here is with the very last table that we looked at, school types. So we have this school type abbreviation field, and if we remember from when we were looking at school statistics, there was also a field in there to keep track of what school type a particular school was. That one's also called school type abbreviation. We're going to create a relationship between those two fields, because if we go and take a look at the actual data, you can see like we have EMS and ELS, and we have EMS and ELS. They're containing the same types of values. You need to have relationships between fields that are going to store the same values. So I would want to have it between school type abbreviation and school type abbreviation, not say school type abbreviation and school type name. That's not going to work. Access needs to see the same value on both sides of a relationship. I'm going to go ahead and close out of these tables now. It's important that you have your tables closed before you go and try to create a relationship. You'll get an error if you try to create a relationship when a table that's going to be involved is open. When we're looking at our tables here, we need to figure out which one is going to be the main or parent table. And that's going to be the one we're going to start from. Generally speaking, if a field is involved in a key, that's going to be an indicator that should be our parent table. So we have school type abbreviation is a part of the key here in school types. It is not part of the key in school statistics. So that means I'm going to go and use school types as my starting point. This is going to be my parent table. I want to click on school type abbreviation here with my mouse, and I'm going to drag over and let go on top of school type abbreviation under school statistics. That's going to open up this edit relationships window. And you can see our parent table is going to be the one that's listed on the left here. The one we let go on when we were holding our mouse and dragging is the related table. So our parent here is school type abbreviation. The related or child table is the school type abbreviation under school statistics. Now in this case, there's just one field in each of these tables that's part of this relationship. You can have cases, and we actually will in this database, where there will be multiple fields involved in a relationship. So up top is where we specify the tables and the fields that are going to be part of the relationship. Down at the bottom, there's these checkboxes here that we can control settings for how exactly this relationship is going to work. Referential integrity is a feature that's designed to prevent what are called orphaned records. Orphaned records are when you have a record in a related table that does not have a corresponding record in the main parent table. So that would be like if I had in school statistics a record for school type for like maybe CHR for a charter school, but there is no CHR type here in the school types. That would be an orphaned record because it's a piece of data that's supposed to have something that it's associated with, and that other piece of data isn't there. That's bad. We don't want that to happen. By going and checking the box to enforce referential integrity, Access is going to make sure that doesn't happen, because it's not going to allow us to make a change to our database that will result in orphaned records. I can't insert, delete, or update a record if it's going to lead to an orphan when referential integrity is checked. If I have referential integrity checked, I can also check boxes for cascade updates and cascade deletes. What Cascade Updates does is if I change a record in the parent table in school types, it's going to automatically update any corresponding records in school statistics in my related table. So if I were to change the abbreviation ELS for elementary schools to be ELM, it would go to school statistics and update all the ELSs to ELMs there automatically if Cascade Updates was checked. If it's not, it's just not going to allow me to make that change in school types as long as there are ELS records in school statistics, because that would create orphaned records. Cascade Deletes says that if I delete a record in my main table here, it's also going to delete any records in the related table to avoid creating orphaned. Cascade Updates is normally considered to be pretty safe. Cascade Deletes, though, can cause problems because when you go and delete data, it's hard to undo that. It's hard to get that data back. And with Cascade Deletes, it can be, one thing that maybe you accidentally delete a record in one table, and it can end up triggering other deletes that can take out huge amounts of data. So for that reason, a lot of times people might use Cascade Updates, but they won't do Cascade Deletes. In the instructions for this project, it said our relationship should just have referential integrity. It doesn't say anything about Cascade Updates or Cascade Deletes. So I'm going to set this up so that we enforce referential integrity, but I'm going to leave these other two boxes unchecked. Go ahead and click Create here. And you can see we now have a line joining these two fields. And when you have a line that has the symbols here, this is saying that it's one to many, that means that you have referential integrity enforced. If I didn't have it on, it wouldn't have those symbols. Go ahead and put it back on here, and I'm going to save my changes to the database because I do need to go and save any changes I make to relationships here. It's not just going to automatically be stored. Okay, so school types, that is the only relationship that it has, is just to school statistics. For schools, it's going to have a relationship to school statistics as well, and it's going to be on this school ID field. And if we look here, school ID is part of the key in schools, but not in school statistics, so I'm going to make schools be my parent table, and then school statistics will be my related table. So I'm going to start with school ID under schools. I'll drag over to school ID under school statistics, and I'm going to turn on referential integrity, and we'll click Create here as well. Let's take a look now at our district statistics table. It has some fields that are going to actually show up in relationships with other tables. So let's start off here. We have the district field that's part of our key. If we take a look at our other tables, we can see in the districts table, it has a district field as well. The idea here is that for the school districts, the statistics for each year are going to be in the district statistics table. So we want to have a relationship between the district fields in those two tables. Now, in this case, district is part of a key on both sides of things, but it's the primary key in districts and just part of the composite key in district statistics. So I actually want to make the one where it's primary key, which is the districts table, be the parent. So I'm going to click on district over under districts and drag over to the district statistics one. I'm going to go ahead and enforce referential integrity here, and we'll tell it to click Create. If we take a look at district statistics, we want to have a way of being able to tie it into schools. And there's nothing here that directly ties into the schools table. But we do have stuff that ties us into school statistics. We have the school year, so we can go ahead and match up the school year. And then while this one's district, we have a managing district field in school statistics. And if we go and take a look at the values that are in those two fields, we can see essentially they're the same. It's basically which district is managing a school for a particular year is the managing district. We're going to go ahead and create a relationship that's going to involve those two fields between district statistics and school statistics. In CS 101 assignments and in many real-world databases, you're going to find that the fields that are on both sides of a relationship are going to have the same name or something that's very similar. So like here, school year, district, managing district. More often than not with CS 101, their names are going to be identical. I'm going to go ahead and take a look at these two tables, and I can see that district and school year are part of the key here in district statistics. They are not part of the key in school statistics. So I'm going to treat district statistics as being my parent table for this relationship. I'm going to start off with one of the fields with district, and I'm going to go and drag over to managing district, which we said was the related one, under school statistics. Here, I need to go and specify a second field that's going to be part of that relationship. Since we said that there's two fields, we need to specify all of the fields that are part of the relationship here at the same time in this dialog box. From district statistics, I'm going to go down to another row here, and I'm going to choose school year. Under the related table from school statistics, I'll choose school year there as well. And then I'm going to check to enforce referential integrity, and we'll click create. So you can see now we have two lines between these two tables here, one for each of the fields that's involved in the relationship. At this point, I'm actually done creating the relationships for this database. There is one other potential relationship we could make, and that would be between managing district under school statistics directly to district under the districts table. But since I'm storing stuff for school year here to go along with the school, I kind of want to route it through district statistics, and I'm just going to forego having that direct connection here in this case. I'll go ahead and save my changes, and I'm going to close the relationships window now. To finish things up, I'm going to compact and repair my database. On the Database Tools ribbon, I'll click the Compact and Repair Database button. Just as a reminder, if you're storing your database in something that you're syncing with OneDrive or Dropbox, you may need to pause syncing before you're able to compact and repair database. Otherwise, you could get an error that the file is in use. At this point, we're done. You can go ahead and close out of Access and submit this participation project.